All right, so in lab, we are moving on to minerals, okay? We did a couple fun things in the very beginning. Now it's time to buckle down and do the, hold on, I have this giant pop-up on my screen for some reason about subtitles. There we go, it's gone. Minerals in lab is way longer than minerals in lecture. All right, as I told the folks yesterday, there is an opportunity, should you decide to punish yourself and become a geologist, there is an opportunity for you to take 14 weeks on minerals, an entire semester. And probably if you chose to be a mineralogist, yes, that's a job, you would take even more classes in minerals. We got one chapter in our book, and I've boiled it down to, I don't know how many slides. We'll say, 24 slides, okay? You're going to come across some stuff in there that I just don't think is relevant at this level. A lot of stuff about crystal structure and so on and so forth that we kind of just glaze over. Now, I do talk about crystal structure, but not to the extent that some of the textbooks do. Why am I mentioning this so much? Because we actually finally have an entire chapter for you guys to read. Unlike the majority of the stuff that we've just got done talking about that came from scattered places all over your book, this, I'm going to hazard a guess and say, is chapter 3 in your textbook. Okay? At least for geology. In earth science, it's possibly even blended in with the rocks chapter. I think it gets its own chapter, though. All right, so again, if you are someone who really it relies on and enjoys reading the textbook, well, you now have that opportunity, okay? Just with that caution that if you read about it in the book, but we haven't talked about it in here, do not expect to see it on the test. If you have questions about it, you could always ask me. All right, and I may or may not. I'll attempt to answer the question. I am far from a mineralogist, okay? I don't want to say I know the 32 we look at in lab. I know a few more, but I'm surface processes and critters. Okay, I'm a vertebrate paleontologist. I don't do minerals, but I get it. I understand their importance, especially at this level and so on and so forth. But they're not my thing. So that being said, again, if you see it in the book, but we don't talk about it, don't worry too much about it. If I talk about it and it's not in the book, there is definitely a chance that it'll be on the test. So again, I continue to test from lectures, but the book is great backup and support for us. Gabish, we good? All right. So, actually, we just kind of talked about this in the test review a little bit. I mentioned there's this very question on the next test. Blank are composed of one or more elements, and you're going to choose, hopefully, the word mineral and not compound. All right, and as I said, when they're together next to one another on a test, they do get a bit confusing because the definition, for lack of a better word, is sort of similar. Minerals can be divided into two piles, if you would. Some are composed of only a single ingredient. Diamonds. Diamonds are only made of what, you guys? Carbon. Good. Copper. Copper is only made of? Copper. And so on and so forth. Gold is gold, silver, silver. And even though we could rattle off a half a dozen, maybe a dozen of them right now, the majority of them by far are more than one ingredient, compounds, okay? And you'll learn that as you're writing the formulas out. Please take the time to write out the formulas when you're doing your mineral lab. We do use those to assign mineral groups, which is half of the mineral practical. For anyone in geology, you've got to take the mineral practical. You folks in earth science will be hearing this later in the semester. You guys do not have to take the mineral practical. But mineral groups are super big in lab. Again, in here, they'll get 10 minutes. And this is a nice example of how we split up things between lecture and lab. luckily for you guys, out of the 100 and some, and don't write this down, it's just narrative, and you guys have access to these slides. Out of the 100 and some odd elements, yeah, because they're composed just of carbon. One ingredient. Elemental means one ingredient. So diamonds are elemental in that they are composed strictly of carbon. So out of the 100 and some odd elements that you see in that periodic table, strangely we don't use them all that much. They're all around here and there. Trace elements, you've heard that word. All right. There's really about 8 or so that show up over and over and over again. And out of those 8, there's 2 that account for 3/4 of the bulk of all this. And this is in the crust, by the way. This is in the crust. We're not looking at the earth as a whole. Mantle is a completely different beast. Okay? But most of our work that we do, all of the mining that we do, and so on and so forth, we're talking about the crust. It's kind of like when we did the seasons thing, and we took it for granted. We were talking about the northern hemisphere that we live in. So a lot of this stuff is from the perspective of the crust. It always says that, but it can be easily glazed over. So those 2 that make up the majority of everything are you're going to hear about over and over and over again: oxygen and silicon. Yes, sir?
Is the oxygen down specifically in the mineral oxides, or is it more than that?
Well, what would it be by more?
Honestly, I don't know.
Okay.
Felt like it was
It's not. Generally speaking, we don't think of it as being a gas in the crust. There's certainly some folks out there that are still putting forward this giant internal ocean thing. If you've read anything about it, you guys out there, it's kind of a neat idea. Okay, there's folks that are certainly arguing that there's pockets of vast pockets of water in the crust. I don't think they could make it in the mantle, but it's been a while since I've read those articles, so I think they're. No, they've got data. They've got data. Yes, sir. It's our next 6 slides. Yeah, so for you folks that can't hear that on the recorder, he's like, is that why all those minerals in lab saw SiO2 over and over and over again? Yes, they're called the silicates. And heads up, if you don't know the mineral group on the test, guess silicate, because more than half of them are silicates. Okay. Now I don't want to see silicate. Just write it down every, because I'm just going to put a big old line through that. But when in doubt, yeah, guess silicate. It's a good guess. So oxygen was not number 1 in the atmosphere, but it does, quite surprisingly, pull up number 1 again by far. I don't know, double almost, as number 1 in the crust. Okay, silicon comes in at a distant second. Now, do not worry about these except for the first 2, and please feel free to round, despite how I yelled at you in lab for rounding. All right, oxygen 47%, silicon 28%. You add them together, you get 75%. You need these stinking decimals, because if you round everything up, you end up over 100%, and well, that's annoying. So oxygen and silicon are the big 2. As I said possibly the other day, these are your flour and your sugar of baking ingredients. Okay, they're just ever present. Aluminum coming in at number 3. Iron. All right, calcium, sodium, potassium, magnesium. And despite the fact that there are an awful lot of silicates and SiOs in the lab, you're going to see thrown in some NAs, some CAs. Not too much potassium and magnesium, but again, it's out there. You get into the more complex minerals like orthoclase and stuff like that, you'll see these, and we love to say aluminosilicates and hydroxylated aluminosilicates and all kinds of fun stuff. You guys have a bunch of sulfur group minerals. You don't even see sulfur in here. So minerals that we see in lab are more of a tour, okay, than necessarily representing their presence in the crust. Just want you to see a little bit of everything. And then, like I said, 1.5%. Believe it or not, we should be able to add all that up and still have a little room left. Consists of trace amounts of I don't say everything else, but almost everything else. So going back to what we talked about a couple minutes ago, diamonds, silver, gold, platinum, all of those cool, precious metals. Well, that's why they're so precious. They're all thrown into that 1.5% of total content. All right, there's just not a whole lot out there. Now, if you want to think about how much of that we've mined already over the years, if you could even, start to picture a pile that high or a room filled up with all the gold jewelry we've ever made and so on and so forth, it does, in my mind, what it does best is illustrate how much stuff there is of everything else. Because we've mined a good bit of gold and made a lot of gold over the years into various, objects, let alone gold pieces and whatnot. And silver, for crying out loud, right? So what that tells you is just how much random, plain old boring rock is out there as well. So yes, I'm really trying to drive home a point here. Together, oxygen and silicon make up 75% of the composition of the crust, and they form the most common mineral group as well, the silicates. The silicates. We will come back to and spend a decent amount of time talking about the silicates. That's the group we use to honor the heritage of crystallinity. With the silicon-oxygen tetrahedron crystal structure. All right, so that definition I gave you back on the very first slide was not the definition of mineral that I want you to remember. A mineral is composed of one or more elements. No, that is not the definition. All right? That is like saying meatloaf is composed of loafed meat. It just doesn't really help much. This is the definition. And this is worth 4 points. And as I indicated once or twice so far, you have to write this out. Now, I'm as forgiving as possible on these. Okay? You can do bullet points if you want. I don't need to see complete sentences. But I do need to see more or less those 4 words. All right? Naturally occurring, that's 2 words. But inorganic, crystalline, and fixed. That's the important part there, okay? So a mineral is naturally occurring. A mineral is inorganic. And we'll talk about what each of these means, don't worry. A mineral is crystalline. And a mineral is composed of a fixed set of chemical and physical properties. If you don't like bullet points, I'm going to change the slide. It's the same words. Don't freak out. There's a sentence for you. Some of you like sentences better. Mineral is a naturally occurring inorganic substance with a crystalline structure and a fixed set of chemical and physical properties. Same 4 bullet points, just threaded together. Okay? 4 points, that's almost a letter grade on the 50-point test. Do not write, a mineral is composed of one or more elements. I will mark it wrong. I'm saying that out loud and on tape. Okay? It sort of relieves the guilt from saying it, because I know you're really grasping at straws when you write that down. Because it says like 4 points in parentheses next to the question usually. Well, when it was on paper, it did. Don't lose 4 points on one question. So what do these things mean? Naturally occurring. Well, not to be redundant, but it means it occurs naturally in nature. It's not man-made, woman-made, squirrel-made. It just is. Okay? Sometimes a question comes up, we make so many things nowadays of synthetic sapphires, lab-created sapphires and diamonds. A buddy of mine was in the jewelry business for a while. He said, yeah, you could kind of tell if you know what you're looking for. And that was even 20-some years ago. I'm sure they've just gotten better. the argument comes in then, well, if it's made out of the exact same thing, is it a sapphire? Yeah, I guess. But again, this remains a working definition, okay? We're getting to the point with technology where eventually we'll be able to make probably anything or everything. So don't overthink it. But a great question, nonetheless. Inorganic. All right. While these things are natural, that doesn't necessarily mean they were born. All right. That doesn't mean they were alive or were a byproduct of life. Some things are, minerals not, but some rocks are organic. We'll talk about a few when we get there eventually. Now, if you've had an environmental science class and we talk about the importance of nutrient cycling in there and how we get shelled animals, invertebrates, seashells are a great example of this, where they pool calcium and carbon and oxygen out of the water to help them produce their shells and so on and so forth. Again, great job, great brain, you're thinking, but leave this definition just simple. There are some bigger scope pictures where if you back up far enough, you could quite easily say, yeah, all right, I see your point. Question?
Never mind, if we're working entirely on technicalities like this, then I don't need an answer.
Okay. We paused. Go ahead.
Okay. My dad, who is a physical chemist doctorate, would say that organic chemistry is anything involving carbon. So
okay.
If we're talking like mineral oil, the stuff we pump out of the sea,
yeah,
that is a byproduct of things dying.
Mm-hmm.
So it's not technically a byproduct of life, but it's also kind of a byproduct of life? Is it because it's a natural process and not...
Well, the hang-up in there is that you called it a mineral product. If you get rid of the word mineral product, we don't have to worry about the definition of it being inorganic. My other answer is that, because coal is a great example, it's not a mineral, it's a sedimentary rock, but we think of it as mining, and we mine minerals and so on and so forth. But no, it's a rock, and it just happens to be a useful rock. It's made out of plants. It's carbon, right? I hope you guys all know coal comes from old swamps or marshes. So that's a great example of why we shouldn't say mineral resources across the board, especially when we're talking about gas and oil, which come, for those of you that don't know, from, again, old swamps and or old critters that have died and decayed. The other thing that I sort of talk about, and we'll get to this in sedimentary rocks as well, is that once we talk about going into solution, once we talk about dissolving, you've entered the realm of chemistry. And it's erased. Its history is erased. There's no semblance. You set this seashell in some water. It dissolves into the water. There's no relationship. It's never going to build, well, not on its own. It's never going to build a seashell again. It's just calcium and carbon right now. So that's sort of the other answer on that one. But yeah. So and again, chemistry, I appreciate it now. And when I was in your seats, it was totally not my thing. I loved lab. I didn't take the time to memorize the formulas though, and it eluded me. But I get chemistry now, and I appreciate it. But yeah, again, that would fall into again. It's good you're engaged, you're thinking, but leave these kind of at their, just as they are. And that's, again, the problem. You're going to get this, whatever your major is, you guys are going to see what they teach you as a freshman, they're going to contradict as a junior. All right? It just happens. Well, I know we told you this, but that hardly ever happens. You have to memorize some rules before you could learn the exceptions to the rule, and why the exceptions matter is kind of the thing. But I'd like to think that every business has those, not just science. Crystalline. What does it mean to be crystalline? Well, it means it's a crystal. Not all crystals are pretty, okay? They have to have room. Crystals grow like a head of lettuce or a head of cabbage or potato, whatever. And oftentimes when they grow in very cramped, closed quarters, they don't grow into those nice, pretty quartz crystals or diamonds that you may be picturing in your head. Sometimes they're just nasty little crusty things, all right? But they are solid little building blocks. Legos. I use the Lego example a lot, all right? And every solid thing out there is composed of crystals. Which goes into an argument that some people like to have about water. Is water a mineral? All right. Water does have a crystalline state, but it goes wonkers on that one, and I just stay out of that conversation because I don't have enough of an opinion. This is the important one. They're all important, but this is... So, as I said, we're starting in lab this process of identifying minerals. You've got these tables that talk about these properties, these characteristics, all right? If they varied, if they changed, well, we wouldn't be able to make those tables. And every freshman geology major would say, woohoo, I don't have to memorize these damn things. But you'd have some other way of having to learn it, okay? So it's because of these unchanging properties that we're able to have the science of mineralogy in the first place. But that's only the half of it. It's because of the chemistry that we have, because of the fixed chemistry, that we have those unchanging physical properties. Sort of an ongoing argument between scientists whose science is the most important one. Chemists will argue with physicists, and physicists with chemists, and biologists, well, they realize they're mostly chemistry, but they're chemistry like with a purpose. And in geology, we just kind of sit back and watch them all argue because we're all of them, okay? I always sort of a joke when people say, oh, I registered for geology. It's the easiest science. It's all of the sciences. We try to ease you into them here and there a little bit. And we try to stay away from physics as much as we can at this level. But it's in there, okay? The chemistry, so going back, the chemistry makes the physical, all right? You are what you are because of your chemistry. Your cat is your cat because of its chemistry, and that tree is its tree. A tree because of its chemistry. The chemical makes the physical. So in that argument, the chemistry wins. All right, I'd never admit that to their faces, but chemistry wins. The only way to make halite is by combining sodium and chlorine. Yes, you might see pink Himalayan sea salt. You might see blue ice coming out on the thruway as you drive by Little Falls. You might see this, that, and the other thing. There's always impurities, a little bit here or there, and it's just a touch. They don't really ever try to accommodate for that stuff in these formulas, okay? But salt is always salt because it's always made of the same stuff. And because it's always made of the same stuff, it's always going to taste salty. It's always going to be cubic cleavage. You could go to McDonald's and open one of those teeny tiny little packs of salt, and if you had a hand lens, you would see that every single one of them is a cube. You could go and buy a blue can of Morton's salt, and every little thing in there is a cube. Now that Himalayan sea salt, we've got some on our counter. I can tell you it's not little cubes in there. That's because they broke up these big sheets that they evaporated out. But if you whacked those and got them to break just right, they should go to cubes as well. Those physical properties are set up by the chemical. Okay, I don't want to be labored, but over the years, as I said, it's become more and more apparent to me how important that is. All right, so, I just said that. So the physical properties are unchanging because the chemical properties are unchanging. All right, so naturally occurring, inorganic, crystalline, fixed or unchanging set of chemical and physical properties. Now, I'm not going to mark it wrong if you write unchanging instead of fixed. I don't care. but we need to see those 4 concepts, okay? I do give partial credit, don't worry. If you come up with 2 out of the 4, you'll get a 2 out of 4. It's not an all or nothing kind of thing. But do your best to remember all 4. Because minerals wasn't on the first test, it's also going to appear with the definition of a rock. So the 2 times you actually have to write something this semester are going to show up on the same test. So we'll get to that definition. We'll worry about that definition when we get there. But just a heads up, they're kind of similar. Sometimes that helps people. Sometimes it confuses people. All right. I think this is a good stopping place for today.